So I'm going to type this in. You already beat me to it. -4/3. Make sure you never use a minus at the beginning for your leading coefficients. And another warning, when you go x, how do you type cubed? You have to press the hat button here. So let me zoom out. For exponent, you need to press this hat button above the division, and then you go 3. So it's x cubed, very important. Another warning is, look at how the cursor is just up there by the exponent. Make sure you press arrow sideways to bring it back down. Otherwise, everything is going to be in the exponent. It's going to be a very weird function you've never seen before. Plus 15x squared, there I can just go x2, minus 20. Notice that the x term is missing. Do you see that? There's no x. That's fine. It's still a cubic, okay? So let's see what we got here. I'm going to hit graph. I'm just going to go zoom standard right away. Oh, I see something. Looks like a parabola, doesn't it? But we know better. We know this is a cubic function. So before we start messing around with our window, let's look at this. This is a cubic. Okay, cubic function. What's the degree of a cubic? This just review. Degree is 3, right? What is the leading coefficient? The leading coefficient is -4/3. The fact that it's negative is what I'm interested in. In general, what do we know about a cubic function? What does it, like the standard look of it is this. This is the standard look. It looks like that. Okay? Or it could look like this. It could go up like that. Which one is this case? Is it this one or is it this one? Because A is negative, it is this one. It's going to go down. It's like a linear function. When it's negative, it goes down from left to right. So this is a leading coefficient that's negative. This gives you a leading coefficient that is positive. Okay, so that's one thing to remember. Some distortions of this could be that, let's just graph the one that's going down. It could turn, like it could make a dip like this, go back up, and then continue on its downward path, right? So this is a distorted version of it. It is generally not symmetric, okay? Especially when it's distorted, it's not symmetric. So this is what we're expecting here. Just by looking at it, we're like, it's negative. Because it's negative, it's going to go like this. It goes from Q2 to Q4. That's another thing. That's the end behavior. Do you remember that from yesterday? Vaguely? Q2 to Q4. That's the end behavior. So let's talk about that as well. End behavior. It'd be Q2 to Q4. The other one is Q3 to Q1. It behaves exactly the same as a linear function. Behaves, like the end behavior is exactly the same. Okay? Okay, now that we've talked about all this theory stuff, let's go back to our screen and let's see if we can make this look a little better. This looks a little pixelated, right? There we go. So we're going to go zoom fit. I'm going to try zoom fit. Oh, that's zoom fit. I need to make some changes there. How's it going? Not bad. Former students. Window. So I'm gonna make some changes here. It does that, and I want to continue it here. So I'm gonna go to my window. I'm gonna change X max. I'm gonna double it. So now I have, in terms of sideways vision, I have everything I need to see. I'm going to go further down a little bit. Window, Y min. I'm going to go negative 50, let's say. I see how crosses here. I see how crosses there. Question. Let's go to our window. And so this is where you have to learn to use this wisely. Let's go window. What's my Y max? 2,813. Is that necessary? It's a bit overkill. So let's bring that down a little bit so we're not seeing too much up there. So I'm going to go 200. Let's try that. Oh, now I'm missing this now because I brought it down too much. So let's go Y window, Y max. I'm going to go 400. I don't delete, I just type. I don't know if I've ever mentioned it. You don't have to clear anything in your window. You just start typing and it will overwrite. So this is probably a very good view of it. Mr. Dirksen, what about the other one with the 2,800? Would that have been fine? Yes, it would have been totally fine. But I like to kind of just focus on the x-axis and the y-intercept, right? Like where's it crossing there? And I want to see the low point and the high point. Okay? Those are important to me. Now, let's graph this. But before we do that, we'll collect some information. Let's do the x-intercepts. How many x-intercepts does this thing have? It crosses it 1, 2, 3 times. There are 3 x-intercepts. And a degree of 3 gives you up to 3 x-intercepts, right? So that's, so we're going to go y2 is equal to 0, second, trace, intersect. So let's go ahead and do that. We press y equals, we let y2 equal to 0, and then we hit graph. And now we're going to find all 3 intersections. So this step you're going to have to do 3 times. So second, trace, intersect. Let's find, my cursor is right there, so I'm going to try to find this one out here first, this one. Go close to it. It doesn't matter. Just get closer to it than the other ones. That's basically what I'm saying. Hit enter 3 times. Enter, enter, enter. So the one at the far right is 11.130. Let's do this again. Second, trace 5. I'm now going to move over to that one right there. Enter, enter, enter. That is 1.220. And one more. Second, trace 5. Just a little over. I'm going to go here. Enter, enter, enter. That is negative 1.100. I've got my x-intercepts taken care of. Now I'm going to do the y-intercept. So I'm going to box this in to kind of just collect my info. Y-intercept, do I need my calculator for it? I technically don't. It is negative 20. It is the constant at the end. But let's say you forget that. You're blanking out. You would have to use second, trace, value, and you let x equal to 0. Okay, so second, trace, value, x is equal to 0, hit enter, and there it is. It's 0, negative 20 after all. So we knew that already. That is important to us as well. X-intercept, y-intercept, and then last but not least is those dips, like the dip and the hill, top of the hill. This one and that one. So I'm running out of room here. I'm going to call this the max, and I also need the min. We call them local max, local min, okay? So for the max, you're going to go second, trace, max, obviously. And for the min, we're going to go second, trace, min. Question. Do all cubic functions have the dip, like those two min and max? Do all of them have it? No. Sometimes there's either 0 turns or there are 2 turns. Okay, remember that. 0 turns or 2 turns. So let's go ahead and let's find this dip down here. Okay, so I'm going to go second, trace, minimum. And what you have to do, you have to go to the left of it. So I'm going to go way to the left of it, hit enter. Then you go to the right of that dip, hit enter, enter again. And watch, what is the first number telling us? What is that really for us? When there's an e to the -6, it's 0. So we're going to go 0, -20. So wait a minute. The y-intercept is also the lowest point? Yes, coincidentally, they're both the same, right? The y-intercept is also the lowest point, so that's kind of interesting. Let's find that max right here. Second, trace, max, and you got to go a point that is to the left of that one, so this would be it, enter. Then you go to the right of it, enter, and when it says guess, just hit enter, and there it is. It guessed pretty good. So that's 7.5, 261.25 is the coordinates of that one. I don't have textbooks, but local, max, and min, because there is no absolute max or min when it comes to a cubic. There's just a local, this is a local max and a local min. That's what they would call it, but I don't think you need to worry about that wording too much. My key may have it. So there you go. Now you have everything you need to graph this, okay? Let's use the x-intercepts to figure out our x scale. I go as far as 11 and as low as -1. So my scale here, make sure you label your axes. Let's do the basics here first. X-axis, y-axis. I'm going to go 5, 10, 15 here. And this is going to be -5, -10, -15. So the same scale throughout. For my y, what do I need to account for when it comes to the y-axis? What's the lowest y value you ever get? -20. And the highest y value would be 261. You got to make sure you understand that. 261 needs to fit this thing. So I'm going to go 50, let's see here, 50, 100, 150, 200. That doesn't work. So I'm going to go 100, 200, 300. That will make sure this thing fits. Same going to the negatives. -100, -200. And now that we've determined our scale, we plot everything. So the first x-intercept here is 11.13, so make a big dot there. Then it's 1.22, that's right there. And -1.10 is right there. So these are the three x-intercepts. The y-intercept is at 0, -20. That is actually right there. This is 20, 40, 60, 80, 100. So we're going by 20s here. So that is my y-intercept. Now we're going to do the local min and max. The local min is 0, -20. It's already plotted. The other one is at 7.5, 261. 7.5 is right there. 261. This is 250. This is 260. 261 is right about there. So now you just have to connect those. So watch what I'm going to do here. I'm going to go to my low point here, and just make it look like that, because that's where one of the legs goes. Then I go back to the low point, I go through that x-intercept, I connect to that local max, and I go through that x-intercept, and it goes down like that. Should show this to my art teacher in high school. She would be so proud of me right now. Not back then, though. And last but not least, your equation. I would say pick smart scales to go up by. Like don't use, I don't like 3s, 3, 6, like it just doesn't work. I go by 2s, by 5s, by 10s, by 100s, and so forth, for the most part. I try to pick numbers that will make it easy for me to plot. But please don't use ridiculous scales so that this kind of looks like this, right? You use a scale so big that everything is just so small when you actually sketch it. Like, don't do that. That's also not a good idea. Okay, Mr. Dirksen, do I need to have all of these labeled? No. As long as the points are where they belong, you are fine. Okay. Another no-no is this. Okay, so I'm going to give you some things that they're picky about. So let's say you plot it, you have those points, and you just go like this. They don't want straight connected dots. That's what you used to do, right? Connect the dots. They kind of want that curve appeal, right? They want, because it is actually what's happening, right? So that's one thing to remember. Okay.